It's Advanced Math, Unit 3, Morning Review. Starting off with number 1. The coordinates of the terminal side of an angle are -3, -4. Sketch the reference angle and theta prime, and then write the values of the 6 trig functions. Okay, so left 3, down 4, -3, -4. Terminal side means when you come up from the origin there, the terminal side is all the way around. But when we sketch theta prime, we put the theta at the origin. Which way do I sketch my triangle? To the y-axis or to the x? Always to the x. And theta prime is in here. Where do I put the numbers? Where does the -3 and the -4? Do either one of those go for the hypotenuse? No. Okay, what goes here? And along this side? And then you go through and find your hypotenuse. You either know it, and if you don't know it, you do your Pythagorean's theorem. And I heard a few of you already say it. What is it? It's 5. Does everybody agree? Okay. Now, once you have your image, and your image will be part of showing your work as well, that, like, if you don't do the picture, you don't get full credit. Then you're going to go through and fill in all of your 6 trig functions. So sine of theta, cosine of theta, tangent of theta. And then it's reciprocals. Which one is the reciprocal of sine? The C or the S? C. Cosecant. C or S for cosine? So the secant. And then cotangent for your tangent function. All right. What do I have? What is sine of theta? -4/5. Do you all agree? The reciprocal of -4/5 is still negative. It's, bless you, it's negative. And then cosine. And its reciprocal, still negative, would be negative. And tangent. And it's positive? Yes, and its reciprocal is still positive? Now, according to All Students Take Calculus, what's the only thing that should be positive in quadrant 3? Tangent. And it's reciprocal, and is that true here? Okay, questions on that one? Should those be easy points for you guys on the test? Yes. Okay. Change to radians, 65 degrees. And yes, you show your work. I do not care how easy it is for you to do it in your head. What do I multiply by? If I'm trying to change to radians, my pi should be at the top, my degree should be at the bottom, and then you cross reduce. I'm hoping you guys picked up your calculators. What goes into 65 and 180? At the very least, what works? 5. Okay, so 65 divided by 5 is 13. 180 divided by 5? 36. How many of you need calculators? Just a few? Okay. All right, so that ends up being 13 pi over, and I'd like you to leave it like this. The textbook had you change it to a decimal. Some of you did, some of you just left it like this because that's the way we're used to. If you left it like this, that's fine, but this is the way it's going to be on the test. I will show you the ones that we changed to decimals. Yes? It does not. Technically, that should be there. Should that be 13 pi over 36 radians? Yes. All right. Change to a degree. So this time, there's 2 parts. There's A and B. This time it is a radian. Thank you. Now, it doesn't have a radian there, but we know it's there. Okay, -5 pi over 3. And if I'm trying to get a degree, change to a degree, degree should be at the top. What is it?
180
over pi. Now, and does the pi reduce?
Yes.
Yes, and the radians reduce as well. And then you can cross reduce the 3 and the 80. 3 becomes 1. The 180 becomes
60.
And then you multiply by -5. And don't forget the negative. Negative what? 300 degrees. Some kids mess up because they forget the negative. All right, questions?
Well, I have a question on number 2. So
Mhm.
you don't have to solve everything.
Like plug it in your calculator? No, not when you're changing to a radian. The textbook did ask you to convert this to a decimal. On the test, you'll leave it just like this, 13 pi over 36. Even though it's not a nice, like 2 pi over 3, it's not a nice radian that we're used to, that's fine. It's still a radian. 13 pi over 36. Is this clear? All right. Next one. 5 radians. This is the one that gives people grief every year. Most common mistake is kids will like, well, it's a radian, so it must be 5 pi. They didn't write it, but it's there. Is that true? No. If the pi is supposed to be there, they would write it. The pi is not there, which means it's worked into the 5. There is no pi. Can I still change it to a degree? Yes. If you don't remember what 1 radian is, then you change it the same way you did this one. How did you change this radian to a degree? What did you multiply by? 180 over pi. So you would do 5 times 180 divided by 3.14. This one we do change to a decimal because we're changing it to a degree. When you're changing it to a degree, you do write it in decimal form, if it is a decimal. And it will tell you on the test on something like this, round to the nearest tenth. Right there's a hint, it should be a decimal. Or, what was the shortcut for those of you that remember?
57.8.
Good. What 1 radian is worth, and I heard a few of you say it, 57.3. So you either do 5 times 57.3 or 5 times 180 over pi. And if you plugged in your calculator 180 divided by 3.14, it ends up being that 57.3, just a longer decimal. All right, so that times 5 equals 286.6. And anybody did it this way, did it work out the same?
You got 286.5.
Okay. 286.5. And you don't have to worry because on the test I do work them both out both ways, so when I'm grading I can look at the method you used and know what answer should match it. Got it? And make sure you show your work. Don't just plug it in your calculator and say, oh, I did it there. I need to see work. Yes?
Have you seen like the 5 times 180 over pi? Like you multiply the 180 first and then divide it by pi?
It doesn't matter.
Okay.
You could do 5 times 180 divided by 3.14. That's the way I've always shown it when I did it with you guys. Right now, I just plugged this in separate to show you that it was 57.3, yada, 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 and then times 5. They both work.
Okay.
So your choice. All right. Are we good? Okay. Next one. Evaluate. Cosecant of 315. Either your unit circle you have, we will fill that out tomorrow prior to the test. So study it, make sure you have it. I have some extra blank ones if you want one to practice tonight. If you don't get one from me, you can always print blank ones off the internet. Got it? Okay, really quick. 315, without anything, what's my reference angle?
45.
And cosecant's the reciprocal of what? What is sine of 315, meaning what sine of 45? 1 over root 2, and then reciprocal means you what? Now what do I have to take into account that I haven't yet? Which quadrant? Why does it matter which quadrant it is in? It might be negative. I might get lucky and it's positive, but I might not. All right, 315 is in which quadrant? Fourth, and I'm dealing with sine. People don't think of that C. Sine in the 4th quadrant is what? So what is this? All right, be careful. Make sure you understand those on the test. Because it's in the 4th quadrant, 315 degrees. If this is 270 and this is 360, it's in here. And in the 4th quadrant, sine is negative.
So what's the point in saying like that it's connected to the 45.
So you can get this number.
You can get that number if you look at the
Unit circle?
Yeah.
Yes.
Okay.
If you, that's what I was saying. If you have your unit circle, you can use that.
Oh, I understand.
Okay. All right. How many of you would just use your unit circle on this? Look and find it all in. Okay, how many of you kind of just figure out in your head what's this, what's that, positive, negative? Okay, you do what works for you guys. All right, eventually you want to have them in your head where you don't have to rely on the unit circle. Okay, cotangent of negative 45. Which quadrant is negative 45 in? And cotangent's the reciprocal of tangent. What's tangent of 45? What's tangent of negative 45? Negative 1. Do you guys agree? Now, is it negative 1 because it's negative 45? No. If that negative angle put me here, would it be negative 1 or positive 1? Positive. So it just depends on which quadrant I'm in. I say that because kids see that negative and think, oh, that's automatically going to be negative. That's not the way it works. All right, it did in this case, and so cotangent, I take the reciprocal of negative 1, which is negative 1. Okay, cosine 300. 300 is what angle or what quadrant? What's my reference angle? 60 degrees. What's cosine of 60 degrees? Using your hand trick or have the fact memorized. What is it? 1/2? 1/2? Cosine in the fourth quadrant, positive or negative? Positive. All right. Sine, any questions so far? Sine squared of 270. Remember, I square after I evaluate. 270 is here, 0, negative 1. Which one is sine, the 0 or the negative 1? And I square the negative 1 and end up with positive 1. Okay, tan of negative 60. What's tangent of positive 60? Y over x. What is it? If you're not sure, look at your unit circle. Y over x for tangent of 60 would be what? Root 3 over 1 or just root 3? Which quadrant is negative 60 in? And according to all students take calculus, what is tangent in quadrant 4? Tangent is negative. You're thinking cosine? Okay. Now, again, it's not negative because the angle's negative. It's negative because I ended up in quadrant 4 and tangent is negative in quadrant 4. Got it? All right. Sine of 30 times secant squared of pi over 6. What's sine of 30 degrees? Unit circle in your head or hand trick. What is sine of 30 degrees? 1/2. And then I'm going to square this. Secant. Is pi over 6 also 30 degrees? Okay. Secant's the reciprocal of what? So in your head you're thinking cosine of 30 degrees. Again, hand trick, unit circle, it's in your head. What is cosine of 30 degrees? Root 3 over 2. But be careful, a lot of kids are forgetting this. This is secant, which means I have to what? Flip it. Reciprocal. 2 over root 3. Keep track of those guys. A lot of kids are just finding the sine or cosine and forgetting to take the reciprocal of that fraction. What do I do first? Multiply or raise it to the second power? Good. So I end up with not 2 over 3, but 4 over 3. You square the top and the bottom. You end up with 4 over 6, or you can cross reduce. You decide. All in all, what does this end up being? 2/3. All right, questions? How are we feeling so far? All right, will you guys do me a favor really quick up here? I forgot to type it in, so put name blank, and don't forget to put this in your packet. Okay, put it in your packet. The packet that's due tomorrow for you guys. Yeah. Okay. And your objective sheet, your assignment sheet has a list of everything in what order. All right, next one. -3 times cosine of pi minus cosine of 2 pi. Okay, quadrantals. You either know it or you're using your unit circle. What's cosine of pi? -1. It's right here. This is what I'm hoping you're picturing in your head. -1, 0. What is cosine of 2 pi, which is over here, which is 1, 0? 1. So I end up with what? -3 times -1 is? 3. And this is just straight -1, not minus a -1. What's 3 minus 1? 2. Questions? All right, next one. Sine of 210. Unit circle it in your head. Think of it. What's your reference angle for an angle of 210? 30. And what sine of 30? 1/2. And positive or negative? That does matter. Negative. If you use unit circle, you would see it right away. If you did it in your head, 210 is the what quadrant? Third, and sine is negative. Minus sine of 270. That's this here. What is it? So am I subtracting 1 or subtracting -1? That does matter. -1/2, it ends up being -1/2 what? Plus 1. Guys, fractions, a lot of kids messed up on my fractions last year, like they were treating it just weird, but this is the same as 1 minus a half. If you have a whole, you take away a half, you're left with what? A half. Got it? All right. Next one. This is one I've talked to you about. Not quite sure if it's come up exactly like this, but I do want to remind you that you're going to see something like this on the test, and kids do struggle. Where do you think they struggle looking at the big picture of it? They're like, oh my goodness, is 7 pi over 15 on our unit circle? And they freak out, like, what am I supposed to do? Any thoughts?
It's like 2 pi over 3, right?
It's not 2 pi over 3, unfortunately, because the 7's not divisible by the 5 or 3. Yes?
Opposites of each other, so they cancel out.
Is that what you were going to say? There was another hand up? No? Okay. One more time, but not, we don't want to use the word opposites. We want to use the word starts with an R. Reciprocals. Good job. Okay. Are sine and cosecant reciprocals of each other? So we don't know what the fraction is, but we know whatever this fraction is, this one's going to be the reciprocal of the original. Do you agree? And what happens anytime you multiply reciprocals together? They reduce to 1. You do need to remember that. Now, what if this one was a negative number? Would its reciprocal still be negative? Yes, I've said that before. Reciprocal of a negative stays negative. So then, is it still going to end up to be positive 1? So then, tangent of 5 pi over 4 we can do. You unit circle it, or think of 45 degrees. What's tangent of 45 degrees? 1, which quadrant is 5 pi over 4? 3, and tangent is positive or negative? Positive. Do you guys get it? Yes.
So even if the 7 pi over 15 isn't flipped, it's still the reciprocal, so it's still
Good.
multiplied.
These here should never be flipped. These stay the same. Even when you do, like up here, where was it at? Cosecant of 315. When we did the reciprocal, it stayed 315. It's the evaluating piece that you take the reciprocal of.
Oh, okay.
So something like this would have been negative root 2 times negative 1 over root 2, and they would reduce.
Okay.
So you don't ever flip those fractions. Mateo?
What did you say about the negative? Like if one of them is negative, it's...
It stays negative. So yeah, just like this one up here, if the original one, like say the sine of 7 pi over 15 was negative, its reciprocal would still be negative, and the two negatives would still cancel each other out. So in the end, it's always going to be positive 1. Okay? So what's my final answer? 2. Now, did I address whether this was positive or negative? I don't know if I finished that. Yes? Why is tangent of 5 pi over 4 positive?
Tangent is positive.
Because 5 pi over 4 is the third quadrant? Yes? And tangent's positive in the third quadrant. All right. Cosine of 3 pi over 2. Is that a quadrantal?
Yes.
right here, what is that? 0, -1, what do I end up with? 0. Okay, times. Do you think kids freak out on this one as well? Same reason. Now, why is this one not as nice, or why is the same thing not going to happen as it did on the last one? They're not reciprocal functions. It's a fraction not multiplied, and what else? They have different angles. Do you agree? Any thoughts?
Multiplied by 0.
Good. I heard at least 3 of you say it. It's multiplied by 0. Does it matter what this comes out to be? No. It's a number. A number times 0 is going to be 0. Shall I put a star by this one as well? Okay. Questions? Okay, let's flip it over. Oh, was there one I didn't do? Thank you. Letter K. Okay. I have sine of pi over 2. Pi over 2 is the 90, which is 0, 1. What is sine? 1. Times secant of 2 pi. 2 pi is here. 1, 0. Secant's the reciprocal of what? It is secant's the reciprocal of what function? And so cosine is reciprocal of that's going to still be 1. So the numerator is 1. Okay, at the bottom, 2 parentheses, there's a square. Do you guys see the squared? Okay, pi over 3, that's quadrant 1, that's what, 60 degrees. What's cosine of 60 degrees? 1/2. So, 1 times 1 is 1 over. Do I cross reduce the 2's first, or do I square first? I have to square. 1/2 times 1/2 is not 1. I'm not adding, I'm multiplying. What's 1/2 times 1/2? 1/4. Which gives me 1 over 2 over 4, or cross reduce. What does the denominator become? 1 over, do you guys agree it's 1 over 1/2? Yes? Ask me a question.
You cross reduce with this, okay.
I didn't show it, but yeah, you could, or yeah. Or you can just multiply them together and call that 2 over 4 and then reduce it. 1 over, divide top and bottom by 2, 1/2. Multiply by the reciprocal, you end up with 1 times what? 2. Final answer is 2. Questions? None? Okay. Number 5. Which of the following is not a coterminal angle for theta if it has a measure of 3 pi over 7? Okay. You guys know how to do this one, but we've not seen it as a multiple choice before. Correct? What have we always done? I've given this to you and I've said find a positive and negative coterminal angle. That's what I've asked you, correct? Yes? Okay, same concept, only we're going to eliminate the one that is not. All right, so here's the question. You do have to remember coterminal angles. What do we do? Add and subtract. Okay, I heard one person say it the way we should. Add and subtract 2 pi. 360 is correct, but why do we want to write it as 2 pi? Because it is a radian. Add and subtract 2 pi. Okay, so first thing I'm going to do is recognize if I'm adding and subtracting a fraction with a non-fraction, do I have to find a common denominator? Okay, so 2 pi, what's my common denominator going to be? Okay, so something over 7. If you multiply here top and bottom by 7, what would that give you? Do Do you agree 14 pi over 7, if I were to reduce, is equivalent to 2 pi? So this right here is the number I'm going to add and subtract to see which one of these does not work. Got it? Okay, so 3 pi over 7 plus 14 pi over 7. Where, guys, this one is on the test. Where did I get the 14 pi over 7 from? 2 pi. Do you see that? 14 pi over 7 is really 2 pi, and 2 pi is a complete period, or 360 degrees. Okay, add them together, what do you get? 17 pi over 7. All right, is that one of my answers up here? So is D my answer, or cross it out? Because they're asking for the one that is not, and 17 pi over 7 is. Okay. Now, before I do the subtraction, do I have any other positives here? The 31 pi over 7. Do you see that? So what should I do here to see if that works or does not work? Add it again. I still want to add 2 pi, so what am I going to add? So I just keep doing that until I've checked all my positives. 17 plus 14 is what? 31 pi over 7. Okay, so I am going to discuss that again. I added 14 pi over 7, and then I did it again here because there was still another positive. And 31 pi over 7, is that one of the answers? It's A. Is that my answer, or cross it out? Cross it out. Again, they're asking for the one that's not. Okay, these next two here are positives or negatives?
Negative.
So should I keep adding?
No.
No, I'm going to change to what now? Good. 3 pi over 7, take away what? 14 pi over 7. Go ahead and take away, what do we get? Negative 11 pi over 7. Is that one of the answers? Okay. So, does that mean all of them work, or is there still one I've not yet checked? Okay, there's still another negative. What do I do? Subtract again, and what do I subtract? 14 pi over 7. When you're subtracting, it's the same as adding the opposite, so you're adding the two negatives. Negative 20 what? Is that one of the answers? No. What does that mean then? Which one? C. Is there any way I went from negative, where was it? Negative 11 pi over 7 to negative 25 pi over 7. Am I ever going to hit the negative 18? No. So do you see how and why C is the answer? Do you have something like this on the test? Yes. Have we done one exactly like this? No. But do we know how to add and subtract 2 pi? Yes. Does that make sense? All right. So yes, I definitely want to see work in your workspace. Okay. Number 6 is another one that we know how to do, but we've not seen it in this form, like multiple choice. So I want to talk about like a test taking strategy, like how to work things out. All right, let's take a look. How long is the arc of a circle with 7-inch diameter intercepted by a central angle of pi over 6? Okay. What formula? Yes. S equals theta r. I heard a few of you say SOAR. Is that correct? S equals theta r? Yes? What does theta stand for? Central angle. R is the radius, and S is the arc length. Good. Okay, so how long is the arc? So am I looking for S in this problem? All right. R is... Okay. Now, did anybody hear what he said? Yeah? Let's take a step back. What's theta? And is it okay to leave it as pi over 6? It's a radian. Okay. R is, what do you think a common mistake kids make? R is what? R is 7. Is 7 what r is? No. Why not? Okay, so be careful with that. If they give you diameter, but the formula has a radius, should you at this point in your mathematical life know to change that? Yes. Okay, so if the diameter is 7, what is the radius? Yes. 3 1/2? Yes? I'm going to leave it as an improper fraction. What would that be? 7 over 2. Okay, why do I leave it as 7 over 2 instead of 3.5 or 3 1/2? Are all my answers written as a fraction? Not a mixed number, as a fraction. Yes? Okay, so that's part of the test-taking strategy, guys. If you look at your answers, would it make sense to write your radius as 7 over 2 instead of 3.5 or 3 1/2? Yes. Okay, so when you're doing these multiple choice answers, look at things like that. Same thing with this up here. I'll have kids say, well, can I just change this to a degree and add and subtract 360? Yes, but look at all your answers. Are your answers degrees or radians? Radians. So look at your answers when you're doing multiple choice to kind of help. All right, all fractions. So I'm going to leave my radius as 7 over 2. So what does S equal? What's theta? Times your radius, which we said is? Nothing reduces, nothing cross reduces. What do you end up with? And is that pretty easy as far as the answer being there? Now, there was nothing complicated going on this one. Why did I go over it? Just to discuss the looking at your answers and recognizing they're fractions, not mixed numbers, not decimals. Leave your radius as a fraction. Yes?
So if your theta was a degree, you have to go back and radians, right?
Right here?
So like if the given like theta was a degree instead of a...
Yes, yes. Good question. She said, what if they gave you theta was 30 degrees? Could you plug 30 degrees into this formula? Yes or no? No. You have a formula you learned back in Math 2 when they gave it to you as a degree. That's not what we're using here. Here, theta has to be a radian. You are correct. So if they give theta to you as a degree, you'd convert it to a radian. Yes? All right. 7. True, false. Cosine of 160 equals cosine 200. Kids will automatically say, oh, false, because 160 is not the same as 200. Is that why we should mark false? No, because they might have the same what angle, starts with an R? Reference angle. So let's check. Where is 160? Which quadrant? Second, how far from 180 is 160? So my reference angle is 20 degrees in quadrant 2. Would you agree? Okay, which quadrant is 200? 3. How far past 180? You guys, when you're looking for your reference angle, do you ever use the 90 or 270? No, 180 or 360, always. Okay, so how far past the 180 is 200? So do they have the same reference angle? That doesn't necessarily mean true, though. What do we have to check next? Positive, negative. We're dealing with cosine, and all students take calculus. What is cosine in quadrant 2? Negative. What is it in quadrant 3? So, true or false? True. All right, you do have those on the test. Make sure you go over these. There were homework problems like this as well.
The first step that you want to do is that you want to make sure that they equal the same
Reference.
distance from the reference angle.
Yes.
And then you have to figure out if they're negative or positive.
Yes.
So if one of them was negative and one of them was positive, they wouldn't equal each other.
Correct.
Okay.
So he said first reference angle, second check for positive or negative. That is correct. First you find the reference angle, then you check if they're positive, negative, what their signs are. Okay, next one. Following the same pattern, we look first to see what their reference angle is. Which quadrant is 140 in? If this is 180. And I use 180, never 90. So how far from 180 is 140? So my reference angle is 40, right? Which, if this is 270 and this is 360 and 180, where is 320? Now, do I subtract or add from 270? Never. I use the x-axis always. How far from 360 is 320? Now, does that mean true, just because they have the same reference angle? No, Mateo said it earlier. After you see that they are the same, you then check to see the signs. What is sine in quadrant 2? Positive. What is it in quadrant 4? So are they going to equal? True or false? Does that make sense? Yes.
Are there going to be ones on the test where the reference angle are the same?
Not, I want to say no, but still check them. Okay. So you're saying like go straight to the signs? Yeah, I would still check. Okay. Cosine of theta equals 1/2. Up here it says find both values of theta where theta is between what? 0 and? A reminder, can it equal 0? Look at the equal bar. Yes. Can it equal 360? No. So if you are on this point right here, would you use 0 or 360? 0. The mistake, kids, is when you're here, they'll be like, oh, that's pi, and then they'll go over, that's 2 pi. 0 and pi, not pi and 2 pi. Okay. Cosine of what angle equals 1/2? What's your reference angle? Cosine of what angle equals 1/2? 60, or pi over 3, that's up to you. Now, does that always mean 60 degrees is going to be one of my answers? No. Not necessarily. Is it in this case? Yes, because I'm in quadrant 1 because it's positive. What other quadrant am I in? So 60 degrees in quadrant 1, and what is 60 in quadrant 4? And that's your answer. If you want radians, you can. That's up to you. I don't need all 4. Just 2 degrees or 2 radians. All right. Be careful with this one. Those of you that write it this way, all is good in the world. If you write it the other way, should you know that root 2 over 2 is the same as 1 over root 2? Should you just know that without unrationalizing? Okay, so you're thinking sine of what angle is 1 over root 2? So that's my reference angle. Is 45 going to be one of my answers in this problem? Yes, because I'm in quadrant 1. Why? How do I know I'm in quadrant 1? Positive? So what other quadrant is sign positive? So what do I have? 45 degrees and what's 135? All right. Cosecant of theta equals -2. Cosecant's the reciprocal of what? And I never flip the angle. Theta stays theta. This is what I flip. What's the reciprocal of -2? Okay, think of your reference angle. Sine of what angle is 1/2? 30 degrees? Is 30 degrees going to be one of my answers on this problem? Why not? Because this here is a -1/2, and sine of 30 is positive. So which 2 quadrants is sine negative? 3 and 4. So what is 30 degrees in quadrant 3? You're a step ahead of me. 330 is 4. I'll put that down now. And for this one here, it's what? 210. So 210, 330. Or radians if you want radians. Does anybody want the radian answers? No. We're good? Okay. Tangent of theta equals -1. I put this one on here because I need you guys listening. Most common mistakes kids make when they see 1 or -1 is they automatically think of what? Quadrantals. Which is true when you're dealing with sine and cosine. Is that true when you're dealing with tangent? No. Ignore the negative. Tangent of what angle is 1? 45 degrees. So be careful. Don't see that 1 and think, oh, quadrantals. It's not the case with tangent. Okay, which am I in if tangent is negative? 2 and 4. Do you all agree? What's tangent of, what's 45 degrees in quadrant 2? 100 and in quadrant 4, 315. Any questions?